Welcome to this video where I'm going to introduce you to series. Now this is mainly for A-level maths and further maths students, but others may be interested in getting to know the basics and the language and notation that we use, and indeed what a series actually means. So quite simply, a series is the sum of the terms of a sequence. So if you have a sequence of numbers that follow a particular rule and you add the terms together up to a certain point in this sequence, that's a series. All right. So the most simple example of a series is actually this one here on the screen. And what that means, that I've underlined in yellow, is the sum of the counting numbers from 1 to n. So n is a number, say 50. So that would be 1 plus 2 plus 3 plus 4 up to 50, if that number there was 50. So this means, quite simply, I'll just extend it across here. It means 1 plus 2 plus 3, okay, plus, and then we tend to put 3 dots and then another plus and then whatever the value of n is, the end point, if you like. All right, that's what this means, with just the single r there and nothing else. Okay, and then I'll come to the bit on the right later and you'll see where that comes from. But I'm going to show you a particular case when n equals 100. In other words, the sum of all the numbers 1 plus 2 plus 3 plus 4 plus 5 and so on up to and including 100. Now this was a famous maths problem. It was given to the maths the student Gauss, Gauss, in the 1700s at school. He was asked by his teacher, along with all the others, to come up with the sum of the first 100 natural numbers. And he did it almost immediately by a rather ingenious method. Okay, and this is what he did. He said, let the sequence required, the series, be equal to 1 plus 2 plus 3 and so on, plus, and then as I've done up there, dot, 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 100. Okay, and he looked at it and said, well, actually, why don't we just repeat that but in reverse? Because of course it would be exactly the same as if you did this: 100 plus 99 plus 98 and so on until you got back to 1. So in other words, you've got the same series written in reverse underneath the original one. And of course, if you look carefully, every pair of numbers, top and bottom, add up to the same total, 101. Okay, 101, 101, and even right through, all the way through, right to the end, 100 plus 1 is 101. So he thought, well, that's easy. You've simply got 101 occurring exactly 100 times, yeah, because there are going to be 100 numbers in that series, and each pair adds up to 101. And if you add s and s together, you get 2s. So he concluded that 2 lots of s, so that's an s there, 2 lots of s equals 100 lots of 101. Okay, and therefore if 2 lots of s make 100 lots of 101, then 1 lot of s would be half of that, which is going to be 50 lots of 101. Okay, And 50 times 101, you can almost do in your head straight away, is 5050. And that is the sum of the first 100 counting numbers. Okay? And it comes about very quickly using that. Now, if you look at the formula on the right, you can see that actually that's exactly what this is here. Because in our example here, n was 100. And I've got here a half of 100 times 100 plus 1, which is a half of 100, 50 times 101. Okay, so this works for any number that you wish. So if we wanted the sum of the first 500 counting numbers, we would do a half times 500 times 501. Let's suppose we wanted just the first 10. Okay, the first 10 numbers, 1 plus 2 plus 3 plus 4 plus 5 up to 10. That would be easy because you could do that to check it quite quickly anyway, but let's just do it anyway using the formula. So it would be r equals 1 to 10, okay, like that. And it would be of r, and it would equal a half of n. You see, n is 10 in this case. It's the number above the sigma sign. Okay, and so it's going to be a half of 10 times 10 plus 1, which is 11, but I'll put 10 plus 1 so we can see the formula being used. Okay, well, a half of 10 is 5, 10 plus 1 is 11, so hopefully you can see that that's actually 55. And if you were to check that and add together 1 plus 2 plus 3 plus 4 and so on up to 10, you would indeed find that it comes to 55. Okay, now that's an introduction to really the term series, being the sum of the terms of a sequence. It's also an introduction to the sigma notation, which we use to show a series. And it's perhaps the most simple example of the sum of the counting numbers. All right. In a later video, there will be a proof of this formula and more complicated ones using a process called proof by induction. Okay, and that is something we do in A-level further mathematics, but it's worth having a look if you're interested in this kind of thing. Okay, I'll leave that video there, a short introduction. Take care.